The truth is that few enterprises have considered agent security in depth. What they do know, however, is that today's agents are largely unbounded. They can access the operating system or the shell, and they can access the internet. And here's their posture right now. They are worried, and they're worried a lot, and rightly so. So we've talked about agent identity, and we've said how it is the foundation for all agent security. Of course, with an agent identity in place, we have explained the authorization boundary that defines what a specific agent is allowed to do and how grants are the mechanism for clearly demarcating an agent's capability. But what we do know from experience is that an agent grant is only useful if there's a mechanism that permits or stops, I suppose, the actual execution of an agent or its tools. So here's the enterprise landscape as we see it. And enterprises clearly, absolutely clearly see the agent value. They see it as immense, and it's quite frankly rapidly driving. What they do know, however, is that today's agents are largely unbounded. They can access the operating system or the shell, and they can access the internet. And here's their posture right now. They are worried, and they're worried a lot, and rightly. Exposes environment variables, exposes deployment scripts, cloud credentials, and even potentially destructive APIs. Normal knowledge worker task can become a data leak because that agent can read both customer records, maybe they're on Salesforce, and it can send that same information in an email a little bit later. So we understand this failure. The tool is reachable, the agent has your credentials, and the task never needed the authority to do the work. So I want to set the stage now, Davis. In the last episodes, we covered identity and task scoped authorization. Identity tells the enterprise which agent acted. Authorization says what that agent may do for one task. But today we're going to talk about something that is the final piece of the puzzle. Today is about the execution boundary, that layer that turns policy or grants that we've been talking about into allowed actions or potentially refusal. I am Eric Broda.
And I'm Davis Broda.
Welcome to the Agentic Mesh podcast. So, Davis, I'm going to set out a few potentially controversial stakes in the ground just to frame our discussion. Because what we're going to talk about, I think, is going to lead us to a new architecture, or at least new components in an architecture that allows us to govern and manage agent execution better. First off, we think proposition number one, agents should not run tools locally or call systems directly. This limits risk while also reducing the blast radius. Second, instead, agents should present a grant to an executor, a tool executor, for example. This tool executor is the vehicle that determines what an agent can do, how long it can do it, and then third, we need the capability to actually execute that tool where that grant that we talked about earlier is validated, the scopes, the credentials are all verified, and then if they're verified, the agent will actually be able to do the work, or like I said, maybe reject the work. So this is a new architecture, and that's what we're going to talk about throughout this discussion. But before we do that, Davis, I want to kind of turn it over to you. You've done a fair amount of research around how firms today and what technology exists today where an enterprise can actually control, manage, and secure their agents. So tell us a little bit about where your head's at.
So there are some existing technologies that major AI vendors are coming out with that enable you to secure the agents that you're using with them. And these fall into two big boxes, sandboxed execution and remote code execution. Sandboxed execution is when, rather than running the agent on your local machine and only sending out calls to the LLM itself, you run the entire agent on a virtual machine hosted in the AI vendor's cloud infrastructure. So it's entirely separate from your local environment. And then you clone in specified GitHub repositories into this sandbox environment and allow the agent to work within it. This allows you to still do a lot of tasks on the software inside that GitHub environment, but it also lets you use tools without worrying about an excessive blast radius. This is because all those tools are executing in this remote environment, and they don't have access to anything the developer has except for whatever's in the repo. Now, this is quite useful, especially for the purposes of software development, but it also comes with its limitations. For instance, because GitHub is the source of data or code that you're working on, it's quite difficult to do anything in the sandbox that cannot be contained within a single GitHub repository. You can't really put database credentials or like have a tool that uses database credentials, for instance, because that would mean the credentials are inside your repository, which is itself a massive security breach. Similarly, there's a limitation on like what tools you can get access to and what you can actually do in these situations. So it is quite useful for software development specifically if you only need access to a single repository to get your job done, but it has great limitations in doing any tasks beyond that. And the second sort of solution that the AI vendors are coming to is that of remote code execution. In this solution, the agent still runs locally on your local machine as it currently does. But you are given access to a remote code execution tool, and this tool farms out specific calls to a remote VM on the cloud environment. Now, this still results in most tools running locally. If you have a database access tool, it's still going to run your local environment, have access to whatever credentials that happen. But the general opinion is that the ability to generate code and then run that generated code is a major security risk. It potentially allows an unlimited blast radius, as there is no limit to what is possible when you are writing code and executing it. It'll just do whatever the code happens to tell it to do. And if there are mistakes, the AI gets confused. It's a lot of things. So the idea is take the riskiest operation, the writing and execution of code, and push that to a remote VM where you only get the results back. And this means that you can do some of the riskier operations remotely while still getting a lot of the benefits of having access to your local environment. Now, this only solves this one specific problem. Tools that already come with pre-written code are not going to in any way be impacted by this, and they can still do, and those like tools can still be dangerous. If you have a database access tool and an email tool, it still leaves the possibility open for data exfiltration through email. But it does provide a modest increase in security in order to make it a bit more secure by removing some of the absolutely most risky operations. However, as you can see, there are still gaps in these existing technologies.
So, Davis, that research that you highlighted definitely provides a few options for the enterprise, and it definitely gets them further than where they were before, which is really having no protection necessarily, wide open access, unbounded tools, and potentially unbounded blast radius. So these solutions that you mentioned, we think are worthwhile. So when we offer the next level of capability, and we call the tool executor, it's not that we're disparaging the other two approaches. What we're saying is that there's probably a new opportunity that will get you further into your security and depth posture with agents. And what we're proposing is something called a tool executor. And we think this tool executor is going to be not only a step above those previous solutions, but we think it's actually going to introduce a brand new opportunity for rich security and audit and governance capability. So here's the proposition. The tool executor allows us to, rather than execute tools locally, where an agent acquires a grant to use a tool, those tool requests are redirected to the tool executor instead of executed or accessed locally. They actually are redirected to a tool executor, and the tool executor, which is safely disconnected from the user's environment, will actually execute that request. So when it gets that request, it's going to validate that grant. It's going to, that is sent by the agent that says effectively, this is the tool I want to execute. This is the permissions that show that I have rights to do it. The tool executor is going to validate that grant. And if the grant is valid, of course, it's going to execute that tool and return the response. If that grant is not valid, then what ends up happening, of course, is it rejected. The tool will not execute, and it's going to send the response back. So, of course, the outputs are going to be sent back appropriately, or the rejection reason. Now, I want to actually walk through a little bit about how this actually works. And there's a fair amount of components involved in this, and you'll see them on the screen as we go through it. But there's effectively 8 steps in describing how these execution grants, I'll call them execution grants, and how they actually get funneled safely to the tool executor. So step 1, of course, there's an initiator that kicks the whole process off. They have a request. They send it to a process orchestrator or some other type of orchestrator that governs, what tasks actually get executed in what sequence or order. So the request comes in, the process orchestrator has to answer a very simple question. Which agents are allowed to do this work, and which tools and skills can they use? That gets handed off to what we call a trust authority. This is where we bundle all of the policies related to what can be done and how to actually issue grants. That's all buried in the trust authority. Of course, once the trust authority gets the request, it needs to actually determine which agents are available, which tools are actually available. Are the tools that are requested valid? Are the skills that are requested valid? So the trust authority now gets that information back from the registry, and it says one fundamental thing. It says, I want to be able to create a grant that will allow this agent to execute these tools or require these skills for this period of time, or as a one-shot, you're allowed to do it once. That information gets sent back to the process orchestrator that initiated the sequence of events, who passes it on to each of the individual tasks. Of course, a task is mapped to a single agent. So now this agent has received a task that describes what needs to be done. It's been passed a grant for one or more tools, and it's passed a grant for one or more skills. So the agent, by virtue of the task, presents that grant to the tool executor. So it says, here's my grant. Now I want you to go and execute. The tool executor, as we mentioned earlier, one of the first things it does is it validates that grant. It goes back to the trust authority and says, I received this grant. Did you issue it? Has it been tampered with? Has it expired? And if it passes all of those tests, and the grant is actually valid, it's going to go and execute the tool. And as I mentioned, of course, if the grant is invalid for any reason, that gets passed back to the agent, gets logged, etc. Now, the interesting thing about that is, as we talk about that, is, as you can see, the trust authority, the tool executor, the process orchestrator, every one of these participants are able to have visibility to the actual request. And in particular, the tool executor has the ability to actually log and audit every single interaction with a tool. It can actually identify in an audit log the parameters that came up with that, the successful or not successful response. If it was a non-successful response, then it can actually log the reason. So there's not just the tool execution, but the whole audit logging of all that capability comes, not necessarily for free is the wrong word, but you get it as part of the parcel of opportunity with the tool executor and the other components we talked about in the previous episode. So we think this works ideally for what we call agentic process automation. This is where agents are full participants in the business process. They're headless. They're not attached to a user per se. They're waiting for work. And this works in this context. But we think it actually can extend quite well to coding agents and then eventually to knowledge worker agents. So Davis, tell us how the tool executor may work for coding agents.
So the thing about coding agents, especially when used for software development, is that these agents are working much more closely with a person compared to the agentic process automation case, where they're working in a much more automated way.
Mm-hmm.
And part of what this means is that when you're doing a very automated process, you kind of know in advance at least what sort of tasks you're going to happen. You can figure out exactly what grants they're going to need, what persons they're going to need, basically when you're setting up the process in the first place. But with a coding agent, you're working much more closely with a person in a state where you don't know in advance what these tasks are going to be. So one of the things you're going to need is a limited subset of tools that you've decided are safe for a developer to work with.
Hmm.
These are notably going to exclude some of the more dangerous tools, such as the bash tool, that allow for arbitrary code execution through things like shell commands or running Python code and things like that. So instead of a bash tool, you're going to have like a change directory tool or a list files tool or any of the other tools that accomplish the actual functionality you would need bash for in your day-to-day work, but in a way that's constrained so they don't allow arbitrary execution. And then beyond this, you get into the sort of grants system where if a developer needs something more than the absolute basics, they're going to need to go and they are going to need to request effectively access to these tools. They're going to need to request a grant. And this could be given either as a long-term thing, as like for the duration of this project you have this tool, or it can be done in the same way as APA, where you get a single use every time you're doing the tool, and you send the system sort of, this is what I'm working on, this is what my subtask I'm currently doing is, and it gets evaluated and a grant given based on that. These can be, once again, limited time window, single use. But this entire thing gives developers enough flexibility to actually do their work without significant interruption, while still giving you the audit trail and the ability to limit blast radius that comes with having proper grants, having time-limited grants
Hmm.
for
Hmm.
these tool and skill usages.
Perfect. So we've talked about coding agents, and obviously they're quite popular. What we're seeing, though, Davis, is knowledge workers starting to use Claude Code or Codex, and they're finding tremendous value. But what's the implication here, Davis, for knowledge workers? I mean, the situation's a little bit different, is it not?
Oh, yes, the situation is quite different for knowledge workers than it is for software developers. For software developers, most of what you're going to be interacting with is the code that's in one or more repositories and maybe a few supplemental systems. Whereas a knowledge worker, pretty much everything they're working with is data that's going to be stored in a remote system somewhere. It's like they're looking at databases, they're looking at Salesforce, they're looking at a whole bunch of documents stored across perhaps AWS, but everything is remote. Everything is potentially a data leak risk. And so you can use some components of the same system, for instance, the ability to have a default set of tools, but much more than with coding workers, you're going to need to really make sure that the grants don't give you something that you can use to do terrible things. Like you can't let someone have access to a database and then immediately give them data exfiltration tools like an email tool or a write to different database tool without having a lot of investigation and making sure that the grant is actually valid. Like these are not things that you can by default let people have access to. Like one example might be that you might be able to give someone read-only access to a whole bunch of data sources as part of their like sort of long-term you can do this set of tools, but you can't, if you're doing that, also give them an email tool or a write to database tool or anything that would allow them to get that information from where they are to some sort of external system in case a mistake is being made.
Now, this is a pretty significant issue, I think, for the enterprise. I mean, here's a scenario, Davis, I want to run by you. Um, so somebody's using Salesforce, for example, a knowledge worker. So we're not talking about a developer. We're talking a knowledge worker. Part of their day-to-day job is to access Salesforce, and they're looking at sensitive customer data. The second thing they're doing is they're an employee in a firm, and like any other employee, they're using email. Now, one of the things we found is despite the best efforts at putting controls around Claude Code, for example, or Codex, is sometimes these agents don't necessarily listen to your advice and they'll go out of their way to, they can click on the browser screens if they want these days. We've used GitHub and Git over, we use Git and GitHub as part of our normal day-to-day work. But even then, we instruct, for example, for me, I instruct my agents, and I know I may be a little bit backward on this here, but I don't actually let them do any Git ads or anything that would actually change the structure of a repo. They can read it, of course, but nevertheless, these agents still try to, and I have to stop them, but they still try and do things like that I actually explicitly told them not to. So here's the deal. These agents are not perfect. And when you have an agent that can access Salesforce with sensitive information, and then you can actually access email, there is a possibility, and it may not be a high probability or a high possibility, but there's a possibility, a low probability, that this agent may actually commingle the two activities and send sensitive information. So what we're talking about, and I think what you're talking about, is we have segregated the tool capabilities such that they cannot be acting together. And I think that's actually a fundamental capability. And we try and do that using this tool executor capability in a seamless fashion that makes it easy and unobtrusive for the knowledge worker to actually do their work. Did I get that scenario right, Davis? Does that resonate with you?
Yeah, like that's the sort of scenario that like comes up frequently when you're doing coding agents. Like the agents will try to do something even if you've told them not to. I've run into similar issues trying to get my agents to do the things I want them to do.
Yeah. If you're in an enterprise as a knowledge worker, the blast radius could be very, very significant. So Davis, I'm going to wrap up now because I think we've kind of talked about this one at length. So for listeners who've been along with us on this journey, this closes the series on securing agents for enterprise use. So to wrap up, in our first episode in the series, we highlighted key considerations around agent security. We talked about the need for agent identity. We talked about the need for an authorization boundary. We talked about the things we actually talked about today, the need to have controlled and governed tool execution. In the second episode, we explained in depth how agent security works in the enterprise, how agent identity gives the enterprise a named actor. And once they have that, like an employee, they can attach permissions to that. They can attach roles, they can attach versions, ownership, audit logs, problem diagnosis, all sorts of things to that. So the notion of a persistent, stable identity was the foundation. That was covered in episode 2. In the third episode, we discussed this authorization boundary and how execution grants are used to define what an agent can do, what tools it can access, and which skills it can acquire. Simply put, the authorization grants gives the actor, this agent, a task-based boundary. And it answers what the agent was allowed to do for this task, which tools, which data, skills, routes, evidence requirements, etc., it is actually allowed to consume. But that grant is just the first step. The second step, which we talked about today at length, is the ability to use that grant to actually execute capability, to execute a tool safely, to acquire a skill safely. So hopefully what we've given to you, the listener, is the ability to understand security in depth. Of course, there's more to this. Mutual TLS, for example, is something that we have not covered in here. There's some security infrastructure that's still required. But what we think is, with the fact that agents are starting to do real work, whether they're coding agents, knowledge workers, or in a business process, security is going to be one of the fundamental concerns of any chief security officer, chief risk officer, chief architect, or operations member of an operations staff. And that's why we wanted to make sure that we paid enough attention to what we think is a serious topic, probably arguably one of the most serious topics that need to be addressed before we see widespread agent adoption. Thank you very much for listening, and we'll hope you tune in next week.
See you then.
Bye now.